Today we're going to talk about similar figures again. And the key to similar figures is corresponding angles are congruent. If you prefer that blank is not big enough, you can write the congruent symbol there. And the corresponding sides are proportional. And the scale factor of similar figures is the ratio of the corresponding sides. And we've seen it already before, but the symbol is just kind of a squiggle there. That symbol is used to indicate that something is similar. So just to reinforce that idea one more time, in the diagram below, triangle ABC is similar to triangle PQR. And once again, what we know, if they're similar, what this means is that angle A is congruent to angle P. And notice where they're listed up here. A is the first, P is the first in the triangles. Then we have angle B is congruent to angle Q. And C is congruent to R. Angle C is congruent to angle R. But in terms of the sides here, how do we write that something is proportional? Well, what we do, and again, it's still really important with regard to the order, but when we look at this, we can say AB is proportional to PQ. Notice, AB is the first in the list of the triangle there, triangle ABC, and PQ are the first two letters in that second triangle. And the same thing, we can say BC equals QR. Look at the placement of where they are. BC, second and third, QR, second and third. And then lastly, we could say that AC is equal to PR. But what we're doing here, now that we've written it, is that we have three ratios, and ultimately what happens is, if you just take two of them, we've got a proportion that we're going to use to cross multiply eventually and solve it for. If we take a look here at example 2, determine if the following figures are similar. If yes, write a similarity statement and state the scale factor. So the hard part on this one is we don't have something that says like ABC is similar to DEF or something like that. But what we do have in this particular triangle is we've got tick marks in the corner. So what we've got here is we've got angle C has one tick mark. So in terms of this, angle C is one tick mark in the first one. We're looking to compare whether they're similar. Over here, angle F has one tick mark. Then we go to the two tick marks. Two tick marks is A in the first triangle, and two tick marks is D in the second triangle. And three tick marks in the first triangle is B, and three tick marks in the second triangle is E. And here's our similar figure, and that's the question. The question is, are they similar? Determine if they're similar or not. So once we can get that listed here, then we've got the sides that we can look at in terms of proportions. So CA has a value of 8, and FD has a value of 10. AB, side AB has a value of 12. and side DE in our second triangle has a value of 15. And the last side, CB, has a value of 16, and side FE has a value of 20. And what we want to know is, are these similar? Well, if we simplify these fractions, so you may want to pull out Desmos or use your fraction button on your calculator. But if we simplify 8/10, we get 4/5. If we simplify 12/15, we get 4/5. 12 divided by 3 is 4, 15 divided by 3 is 5. If we simplify 16/20, we still get 4/5. And because all of those values, the 4/5, are the same, are they similar? Yes. In terms of our statement, we can say what we wrote over there. Triangle CAB is similar to triangle FDE. And our scale factor is the 4/5. I do want to say that there's a second option on this one in terms of the scale factor, because there was no given information at the beginning. We didn't say compare the left triangle to the right triangle. Your other scale factor could have been 5/4, because you would have been comparing this one to this one, and sorry, this triangle to this triangle. We look at letter B here again. The question is, and we could even write it over here in our statement if we wanted to, is are these two similar or not? And go back and look at the tick marks. So in this particular case, I think I'm going to write it over here anyway. We've got M has 1 tick mark, and W has 1 tick mark. J has 2 tick marks, and T has 2 tick marks. K has a right angle, and U has a right angle. And L has 3 tick marks, and V has 3 tick marks. And the question is, are they similar? And once we can get that written down here, and what we know with regard to similar figures is that the angles are congruent, we can look at the proportions of the side. MJ has a side length of 6, and WT has a side length of 6. JK has a side length of 12, and TU has a side length of 6. And actually at this point, some of you might already know that we don't have similar figures. But just to check here, and by the way, we know that those aren't similar figures because 6 divided by 6 is 1. And 12 divided by 6 is 2. And in order for them to be similar, we need to have those values be equal. But just for a little bit more practice here, KL is 24 and UV is 16. Again, that's going to give us another number, different number, as well as if we compare ML to WV, which is 14. But no, all of those values are different. 1 doesn't equal 2. And then once they don't equal, we don't have similar figures. As we flip our papers over here, when determining if triangles are similar, there's a shortcut that we can use. Instead of showing that all corresponding angles are congruent and that corresponding sides are proportional, like we just did, all we have to do is show that corresponding angles are congruent. I'm not even going to fill in a blank here. We need to show that corresponding angles are congruent, and this shortcut is referred to as the angle-angle similarity, or AA for short. And it is, if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. Now notice, I was specifically talking about triangles, not about a figure like 2b that we did. This one refers to triangles, but part of the reason that it works for the triangles is all triangles have 180 degrees in them. So if two of them are the same in both, then we have congruent angles, and therefore we should have proportional sides. So if we look at letter 3 here, it says determine if the following pairs of triangles are similar and justify your answer. Well, here's how we can justify our answer to help us determine. Well, 102 degrees plus 30 degrees gives us 132 degrees. And if we subtract 132 from 180, again there's 180 degrees in a triangle, what we end up with is 48. So that means that this angle is 48. So in our first triangle there to the left, we've got 102 degrees, we have 30 degrees, we have 48 degrees. Well, over here, 102 plus 48, how big is this third angle? It's going to be 30. Are these two triangles similar? Yes. They're similar by the angle-angle similarity. We need 3 congruent angles. Ultimately, we need 2. And what happens is, if we have 2, we automatically have 3. If we look at letter B, we need to be a little bit more careful here. We need to think back to a couple pieces of information that we have. And it's been a while since we've talked about it. But this angle right here, angle TUW, is congruent to angle VUX. Do you remember why? And it is because those angles are vertical angles. So even though we don't know what that value is, we've got 55 and we've got another angle, 2 angles there, that are congruent to the 55 and a second angle, and consequently these are similar. If you were unsure, what you could do is you could give a numerical value to angle U. Maybe make it 50. But what you would see then, if here is 50, then here would also be 50. And then 50 plus 55 is 105, minus 180 is 75. We would have the same amount of, the angles would be congruent for both triangles. So yes, these two triangles are similar by the angle-angle similarity. Thirdly, again, we're trying to decide, are these similar or not? We look at our numbers here, we want to justify our answer. And when we look at this particular one, we've got 60 plus 81, which is 141. There are 180 degrees in a triangle. So if we take 180 minus 141, we get 39. So this angle here is 39. In our other triangle, we've got 81 plus 40, which is 121, and 180 minus 121, 10 minus 1 is 9, and 7 minus 2 is 5, it's 59. And are these similar? Well, no, we don't have 3 congruent angles or even 2 congruent angles. So this one is not similar. As we get close to finishing, again, we don't have a value on these, but the way that we can justify our answer is we can say that angle A, which has 1 tick mark, is congruent to angle B. And we can say angle B is congruent to angle E, because each of those angles have 2 tick marks in them. And the angle-angle similarity says if 2 angles of one triangle are congruent to 2 angles of another triangle, then the triangles are similar. Again, that's from the angle-angle similarity. Lastly, which of the following statements are true? Select all that apply. Well, all congruent triangles, sorry, I'm missing an S, all congruent triangles are similar. If they're congruent triangles, are they similar? Yes. All similar triangles are congruent. No, because a similar triangle, all that has to have, we've got 3 congruent angles, but we don't have to have 3 congruent sides. The sides have to be, and similar, the sides are proportional. Let's see, all right triangles are similar? No. If you think about it, we can have a right triangle that has, here's a right triangle, but we might have 45 degrees here and 45 degrees there. And then we might have a right triangle, but we might have 30 degrees here and 60 degrees there. So we don't have 2 congruent angles. Letter D, all isosceles right triangles are similar. And now I need to think about this one for a second, but it's an isosceles right triangle. So we're going to have that, and my picture's not very good, but what that means is that this angle and this angle have to be the same. And if it's an isosceles right, those 2 angles have to be the same, which would mean that we have 45 degrees in each of these. So do I think that these are similar? Yes. That's the only way I can draw that. 3 congruent angles. Letter E, a right triangle with a 30 degree and a right triangle with a 60 degree. So if we drew a quick picture of that, again, it's a right triangle with a 30 degree. And we can say a right triangle with a 60 degree. Are these similar? Well, this would be 60 and this would be 30. So the answer is yes. And lastly, 2 isosceles triangles that have congruent vertex angles are similar. 2 isosceles triangles, so they don't have to be right, but we can pick some angle here. So we're going to say 2 isosceles triangles that have congruent vertex angles, and if there's congruent vertex angles, my picture's terrible there, but if they're congruent vertex angles, we know with isosceles that we've got 2 congruent sides, and therefore that makes these angles the same. So if they have congruent vertex angles, yes, they are still similar.